Hello, welcome to ProTrack Learn to Grow. In this video, we are going to discuss rational numbers. And we are starting rational numbers from its basics. This is the new topic we are starting, so let's get started with the video. The first thing we have to discuss is number system. You must be aware about the number system, alright? So let's discuss the number system first. Let's say, suppose I have a box, okay? Let's say I have a box and I have some numbers in this box. 1, 2, 3, 4. All counting type numbers I have in this box. Now what I do, I add some new numbers in this box only. Alright. I have this box only. I had 1, 2, 3, 4 already. Okay. I have kept a new number here, that is 0. Alright. Now again I kept some new numbers in this box. Alright. In this box what I have already, I have 1, 2, 3, 4 and so on with 0, and the new number which I have added now are -1, -2, -3 and so on. Okay. -3, -9, -11, -15 and so on types of numbers. Okay. So basically what you can observe here in this box, this is the first one, I have all counting numbers. Alright. Now again I have all counting numbers with 0. Now here what I have counting numbers with negative numbers. Alright. So when we are having all the counting numbers together, then they are said to be as natural numbers. Alright. When we are having all the counting numbers, or you can say natural numbers are those numbers, or all counting numbers are considered as natural numbers. Alright. And natural numbers are represented by capital N. Alright. Now in the second box you can see I have all counting numbers, means all natural numbers along with 0. Alright. I have all natural numbers along with 0. When we have all natural numbers along with 0, those numbers are known to be as whole numbers. Alright. And whole numbers are represented as capital W. In the next box you can see I have positive numbers. I have, okay, 1, 2, 3 are positive numbers. Alright. All natural numbers are positive numbers. Then I have negative numbers, -1, -2, -3 and I have 0 also there. Alright. These types of numbers, these numbers will be taken as integers. Okay. Basically what we have did, we have extended our number system. Okay. At the beginning we had only what, natural numbers, then we added some more numbers, one number, that is 0, then we got the whole numbers, then we added negative numbers there, we got integers, and integers are represented by capital Z but not capital I, because integers came from a German word Zahlen. Okay, Zahlen, that is Z, Zahlen, Z-A-H-L-E-N. This is a German word which means to count. Alright. Now let's proceed. We had natural numbers, we had whole numbers, we had integers. So do you think we are with all the numbers here in our number system or in a number line? No. We can have these types of numbers there also, 2.5, 9/8, okay, and we can also have -11/25 and many more numbers like these. Alright. So what do we call these types of numbers? You can say 2/5 is a fraction, 9/8 is a fraction, but can you say -11/25 is a fraction? No, right? Why? Because -11 is what? -11 is an integer basically. But in fraction, what do we have? We have natural numbers. Alright. If we are having a numerator and a denominator in any fraction, both numerator and denominator are natural numbers when we are talking about a fraction. But what do we call the numbers when we are having negative number as numerator or negative number as denominator, or one numerator negative, denominator positive? What do we call these types of numbers? These types of numbers are called as rational numbers. Alright, the concept of rational numbers begins from here only. Alright, and rational numbers are represented by capital Q. Alright, rational numbers are represented by capital Q. Here Q means quotient, because we are having quotient of two integers only there, right? 9/8. Alright, so let's proceed now. This is our number system which we have discussed, which is useful while we will solve the questions. Now, if I say which type of number 2 is, what you will say? You will say natural numbers. That is all right. But the more efficient term which we can use is integer. All right, because in integer we are having vast numbers. All right, integer is a vast number system. All right, so we can use integers in place of natural number or whole number, because in integers we are having natural numbers and whole numbers all along with negative numbers. All right, so we are done with the number systems, and we have discussed an overview for rational number, what type of numbers are considered as rational number, and this 2 by 5 is also a rational number. All right, means a fraction can be a rational number also. All right, because 2 upon 5 is in fractional form, so it doesn't mean that this is not a rational number. This is a rational number also. So let's discuss further to make the concept of rational number more clear. All right, now let's see the definition of rational numbers. Rational numbers, you already know, rational numbers are represented by capital Q. Now let's see the definition of rational number. A number in the form of P upon Q, or a number which can be expressed in the form of P upon Q. Alright, any number that is already in the form of P upon Q, or any number which can be expressed in the form of P upon Q, and where P and Q are integers. This is the main thing here. P and Q, both numerator and denominator, are integers here. Alright, not natural numbers. And Q is not equal to 0 is called a rational numbers. Alright, so two properties which is mandatory here is, first, that should be in a form of P upon Q. Alright, or can be expressed in the form of P upon Q. Form of P upon Q can be like 2 by 5, 3 by 9. Alright, this can be the form of P upon Q. Or the second thing which we have read in the definition is expressed in the form of P upon Q. Like we are having 2. So can you say this is a rational number? Could you say that? Yes, this is a rational number. Why? Because it can be expressed in the form of P upon Q as 2 upon 1. We are having P, we are having Q. That 2, Q is not equal to 0, which is there in the definition. And P and Q are integers. 2 is an integer, right? 5 is an integer again. Minus, okay, here we are having 2. 2 is an integer and 1 is again an integer, plus Q is not equal to 0 here. That is, both the numbers are rational numbers. So the two properties which should be kept in mind for being a rational number is always that number will be in the form of P upon Q, or we can express that number in the form of P upon Q. Like this is the first case. Here we are already having a number in the form of P upon Q, and in the second case you can see here what we expressed a number in the form of P upon Q. We changed something. We did not change something because its value does not get changed when we write 1 in the denominator, but it can be written in the form of P upon Q. Hence, it is a rational number. And the second property which is important is both P and Q should be integers. What comes under integer? Positive numbers, negative numbers, or 0. And the third thing which is important here is Q is not equal to 0, means denominator. Basically, rational number is also numerator upon denominator. Okay, P is numerator and Q is what? Q is denominator. Basically, numerator upon denominator, we are calling it a rational number. Alright, means basically a fraction is a rational number. Alright, but there can be negative numbers also. What? P and Q are integers here in rational numbers, but in fractions, what happens? In fractions, we are having what? Natural numbers. Alright, as numerator. In numerator and denominator, we use natural numbers, not integers. Alright, so these are our rational numbers. Here you can see the examples: 2 by 3, minus 5 by 7, minus 11 by 5, 7 by minus 9. Okay, what is 2 by 7? Is minus 2 is a rational number or not? Yes, of course, minus 2 is a rational number. Why? Because we can write minus 2 as minus 2 by 1. Can we write like this? Yes. Therefore, this is also a rational number. Alright. Let's proceed now. So this is the definition of rational number. How do we represent rational number? By capital Q. And the important things which should be kept in our mind for being a number as a rational number, we have studied. Okay. Now let's proceed now. Okay. Now there is a difference between fraction and rational number. The basic difference we have discussed already. Okay, what I have discussed in the first slide is all fractions are rational numbers. Alright, means if I have 2 by 5, 2 by 5 is a rational number also. Why? Because 2 and 5 both are integers. 2 by 5 is in the form of p upon q, and the third thing is q is not equal to 0, means denominator is not equal to 0. Hence this fraction is considered as what? This fraction is considered as rational number also. It is a rational number. Alright, now the things which we have to study is the first point of fraction says p and q are natural numbers. When we are talking about fractions, fraction is p upon q can be a fraction also. Alright, means numerator upon denominator is fraction basically. Alright, p upon q is also a fraction. Therefore p and q are natural numbers, but when we talk about rational numbers, p and q are what? P and q are integers. Okay, integers. Under integers what we have? We have negative numbers also. Alright, now second point of fraction says all fractions are rational numbers. Here you can see 2 by 5, I have 1 by 5. 1 by 5 is again a rational number and a fraction also. Alright, if I say 12 by 15, 12 by 15 is a fraction and this is a rational number also. Alright, but the second point of rational number says not all rational numbers are fractions. Alright, every rational number is a fraction. It is not mandatory. How? If I have, let's say, if I have, let me write here, if I have minus 1 by 5. Alright, this is a rational number. Yes, this is a rational number. Why? First, this is in the form of p upon q. Second, p and q both are integers. P and q are what here? Minus 1 and 5. Alright, minus 1 and 5 both are integers. And the third thing is q is not equal to 0, means denominator is not equal to 0, but that is 5. Therefore, all the three conditions are satisfied here. Therefore, this is a rational number. Alright, but can you say this is a fraction also? No, this is not a fraction. Why? Because here minus 1 is an integer but not a natural number. But what do we have in fractions? We have p and q both as a natural number but not as an integer. Alright, so what happens? Every fraction can be a rational number, but every rational number can be a fraction is not mandatory. Alright, this is the difference between fraction and rational numbers. Don't be confused. Alright, let's proceed now. Now we are having some useful results which will be useful while solving the questions. Alright, basically I have discussed all the rules before, means I have discussed in the last slides already, but now we will discuss them more clearly. Alright, so the first point says every natural number is a rational number. Every natural number can be a rational number, but what does this point say? Every natural number is a rational number, but a rational number is need not to be a natural number. Okay, now let's understand this. This is the first segment of this statement, this line, and this is the second segment. Okay, let's discuss the first segment first. Okay, first segment says every natural number is a rational number. Natural numbers are what? 1, 2, 3. And what is a rational number? Rational number is any number which can be represented in the form of p upon q, where p and q both are integers and q is not equal to 0. So these are our natural numbers 1, 2, 3. Alright. Now can we express these 1, 2, 3 or these natural numbers as rational number? Right. We can. How? We can write 1 as 1 by 1, 2 as 2 by 1, 3 as 3 by 1. Therefore, now these are in the form of p upon q, where p and q both are integers, because in integers natural numbers are also included, and p and q both are integers and q is not equal to 0. Hence, every natural number is a rational number. Okay, the first segment is completed. Now let's see the second segment. Second segment says a rational number is need not to be a natural number. It is not mandatory that a rational number will be a natural number also. If suppose we are having minus 2 by 5. Is this a rational number? Yes, this is a rational number. How? Because minus 2 by 5 is the form of p upon q first. Second thing, p and q both are integers, means minus 2 and 5 both are integers. Third thing, q is not equal to 0, that is denominator is not equal to 0. Hence, this is a rational number. Alright, this is a rational number, but is this a natural number also? No, this is not a natural number. Why? Because natural numbers are not in the form of p upon q. They are simply as 2, 3, 4, 5 and so on till infinity. Alright. Therefore, what this point says, every natural number is a rational number, but a rational number is need not to be a natural number. Alright. This 2 can be written as 2 by 1. So this is rational number also and natural number also. So a rational number can or cannot be a natural number. Alright. So this is the first point we have to discuss. Now let's see the second point. Second point says 0 is a rational number. Okay. 0 is a rational, when we are saying 0 is a rational number, how we can say 0 is a rational number? Because 0 is not positive, not negative. Okay. So if I have 0, 0 can be written as 0 by 1. 0 can be written as 0 by minus 2. 0 can be written as 0 by 100, and any number can be there as denominator when 0 is a numerator. Alright, and these all will be equal to what? These all will be equal to 0 again. Means the value of 0 is not getting changed when we are giving any denominator to it. Hence, we can write it in the form of p upon q. P and Q both are integers, 0 and 1, 0 and minus 2, 0 and 100, both are integers. Alright, because in integers what we have positive numbers, negative numbers and 0. Therefore, P and Q both are integers, and the third thing, Q is not equal to 0. Q is what? Denominator. Denominator is not equal to 0, hence 0 is a rational number also. Alright, let's see the third point. Third point says every integer is a rational number, but a rational number need not to be an integer. Here also we are having two segments. Okay, first segment is every integer is a rational number, but second segment is a rational number need not to be an integer. Okay, integers are what? 1, 2, minus 4, 0. These are our integers, positive, negative, 0. Okay, so what we have said here, every integer is a rational number. How? Because every integer can be written as 1 upon 1, 2 upon 1, minus 4 upon 1, 0 upon 1. Can we write it like this? Yes, of course we can write it like this. Therefore, every integer is a rational number. But second segment says a rational number need not to be an integer. If I have 2 by 5, so is this 2 by 5 is an integer? No, because integers are not in the form of p upon q. Alright, therefore third point is a useful result from rational number that should be kept in mind. Alright, now let's see the fourth point. What the fourth point says, every fraction is a rational number. Here also we are having two segments. Every fraction is a rational number. We have discussed this already, right? But let us discuss it again. But a rational number need not to be a fraction. Here we are having two segments. Every fraction is a rational number. Fraction can be 2 by 5. Fraction can be 9 by 5, 9 by 8, 13 by 16. Any fraction we can have, right? So can we say this is a rational number also? Alright, yes, this is a rational number also. Why? Written in the form of p upon q. P and q both are integers and q is not equal to 0. Hence they are rational number also, and they are fraction also. Okay, but according to second segment, rational number need not to be a fraction. If we are having a rational number minus 3 by 8. Minus 3 and 8 both are integers. Alright, but this is a rational number. Yes, this is a rational number, but can this be a fraction also? No, this is not a fraction. Why? Because there we are having minus 3, and minus 3 is an integer. This is not a natural number. But when we talk about fraction, we have numerator and denominator as what? As natural numbers. Alright, so these are the four important points which we should keep in our mind to solve the questions on rational numbers. Alright, let's proceed now. Okay, now we are having positive rational number and negative rational numbers. Let us discuss these positive and negative rational numbers. If numerator and denominator either both positive or both negative. If numerator and denominator are either both positive or both negative. So what does it say if we are having a rational number like 2 by 5? This is a rational number. Yes. So here 2 and 5 both are positive integers. Alright. So this is a positive rational number. If I have minus 3 by 5, is this a positive rational number? No, because this is here in the numerator we are having minus sign, but in the denominator we are having plus sign. The answer which we will get after dividing it, we will get a decimal number here, but that number will be negative. Alright, therefore this is not a positive rational number. But if I say I have minus 3 by minus 5, so this minus can cancel out this minus, okay, and this will be written as simply 3 by 5, means as positive 3 and positive 5. Alright, so these types of rational numbers are positive rational numbers. Numerator and denominator, either both should be positive or both should be negative. Here both are positive and both are negative. Only these types of rational numbers are considered as positive rational numbers. Now if we talk about negative rational numbers, here what happens, numerator and denominator should have what? They should have opposite signs. Okay, if numerator is positive, then denominator should be negative. If numerator is negative, then denominator should be positive. If they will be having same sign, the same sign will cancel out each other and it will become positive, right? So here if we are having a negative rational number are if the numerator and denominator are such that one of them is positive integer and other is a negative integer, or we can say both numerator and denominator are of opposite signs. Alright, so these are positive and negative rational numbers. Let's proceed now. Now we are having some questions. Let's perform them. Let's perform the calculations for these questions. Okay, so the first question says, what do it say? Write down the rational number whose here should be numerator. Okay, whose numerator is minus 3 into 4 and whose denominator is 34 minus 23 multiplied by 7 minus 4. Okay, numerator should be what? Numerator should be minus 3 into what? 4. All right, and denominator should be what? Denominator should be 34 minus 23 multiplied by 7 minus 4. So first of all, let's what we will do, let's simplify them. Here we are having minus 3 into 4, so minus 3 into 4 gives us 4 into 3 gives us 12, and here we are having minus and plus minus gives us minus always. All right, so we will get minus 12 here. All right, now if we will solve this, first of all we will solve the brackets, right? 34 minus 23, what does it give to us? It gives us 11. All right, now in the second bracket what we are having, 7 minus 4, it will give us 3. Okay, so this will give us 11. All right, and this will give us 3. Okay, so 11 into 3 gives us 33. Now how do we represent a rational number? Rational number is represented in the form of P upon Q, where P is what? P is numerator and Q is denominator, and we are having the value for numerator and denominator already. Numerator is equal to minus 12 and denominator is equal to 33. Hence this will be the rational number. All right, now let's proceed to the next question. The next question we are having, write the following rational number as integers. We have to write these given rational number as integers. Okay, the first rational number we are given with 7 by 1. So 7 by 1 is always equal to 7 because 1 not changes its value. Therefore 7 is an integer. Okay, second we are having minus 12 by 11. Minus 12 by 11 is again equal to minus 12 already. Okay, so minus 12 is an integer, change from rational to integer. Okay, third you can see here 34 by 1. 34 by 1 can be written as 34, and 34 is an integer. Under integer what do we have? We have positive numbers, negative numbers along with 0. All right, okay, next we are having 73 by 1. 73 by 1 we are having, so 73 by 1 can be written as what? Minus 73. So minus 73 is an integer. Again what do we have? We have 95 by 1. 95 by 1 can be written as 95. So here you can see, if we are given with any rational number and we have to convert them as an integer, what do? We just remove the 1 from denominator. We just remove the denominator from there, because in integers we do not have any denominator. That is a simple number. Alright, so let's proceed now. Now we are having, write the following integer as rational number with denominator 1. Okay, now we are given with integers. In the previous question what do we have? We are given with rational number and we have converted them into integers. Now in this question we are having integers and we have to convert them into rational numbers with denominator 1. If we are converting any number, any integer into rational number or any natural number into integer, we will always use denominator as 1. Okay, so let's solve this question. Nothing we have to solve, we just have to write them as a rational number. Okay, so minus 15 can be written as minus 15 by 1. All right, okay, this is changed into rational number. Then 17 can be written as 17 by 1. This was changed into rational number. And third we are having 85 can be written as what? 85 can be written as 85 by 1. This is changed into a rational number. Then we are having minus 100. Okay, we are having minus 100. Then this minus 100 can also be written as minus 100 by 1, changed into rational numbers given with integers, and we converted them into rational number by writing denominator as 1. Alright, let's proceed now. Okay, in the next question we are given with write down the rational number whose numerator is smallest 3-digit number. Okay, numerator is given as the numerator is smallest 3-digit number. Smallest 3-digit is what? Smallest 3-digit. Okay, let's see. If we talk about 2-digit number, the largest 1-digit number is 9. Okay, and the smallest 2-digit number is the first number that will be starting as a 2-digit. That will be the smallest 2-digit number. So the smallest 2-digit number will be 10. Okay, then largest 2-digit number will be 99, because after 99 we do not have any more 2-digit numbers. Okay, then if we start, then after 99 we get started with 3-digit numbers, and after 99 it comes 100. So this is the smallest 3-digit number. So numerator is smallest 3-digit number, that is 100, and denominator is the largest 4-digit number. Okay, if we proceed here, but we are having smallest 3-digit number as 100. Okay, and the 3-digit number will get end at 999. all right, and after 999 we will not have any more 3-digit numbers, and we will get 4-digit numbers then. So 4-digit will be 1000 then. Okay, now if we will proceed on, we will get largest 4-digit number as 9999. After this 9999 we will get what? All right, we will get this, we will get 10,000. all right, so what is the largest 4-digit number? Largest 4-digit number is 9999. After this we will get 10,000. all right, so we have to write it as a rational number. Rational number is in the form of P upon Q. P upon Q is nothing but numerator upon denominator, and numerator is what here? Numerator is 100 and denominator is 9999. So this is the rational numbers we have. Rational number we have formed with the given data in the question. all right, okay. Now these are your practice questions. Do them. In the first question you have to tell which rational number is positive, and the second question, what you have to do is you have to form a rational number with the given data in the question. You can drop your answers in the comment section below. Okay, so this much for this video. Thanks for watching.